Hey guys, welcome back to another video on chemistry. Today what I'm going to do is record a video on naming ionic compounds and naming covalent, also known as molecular compounds. So let's go ahead and get started. Not going to go over the whole thing, but a few key questions that I felt like I really needed to cover one last time, okay? All right, so let's get started. Here is cation versus anion. Quick reminder, cats have positive, right? So that's how you remember cations are going to be positively charged. At the same time, anions are going to be negatively charged, okay? How do you gain a positive charge? By losing electrons. And how do you gain a negative charge? By gaining electrons, right? So, for example, if I had 3 protons versus 3 electrons, just like that, notice that the overall charge right now is 0, right? Nothing. It's neutral. However, if I add an electron, just like that, my overall net charge is going to be minus, right? 1 minus. Now, this time, what if I take away a negative, just like that? My overall net charge is going to be 1 positive. Okay, so that's what I mean by you gain electron, then you become negatively charged. You lose an electron, you become positively charged. Okay, so to give an example of each, calcium has 2 valence electrons. When it loses 2 electrons, right, it becomes calcium 2+. That's an example of a cation, calcium cation. Let's do fluorine. Fluorine has 7 valence electrons, right? It's on group 7 and it's under group 7. So there's 7 valence electrons, which means it has 7. It needs to gain 1 more electron to satisfy the octet rule, right? So what's going to happen is it's going to gain 1 more electron here, and it's going to become just like that, negatively charged. All right, so that's a fluoride ion. All right, moving on forward, I have number 7 here, magnesium and chlorine. Okay, show the Lewis-Dot diagrams for magnesium and chlorine atoms. All right, so I'm going to go ahead and draw magnesium. Magnesium has 2 valence electrons and chlorine has 7. Right, done. That's it. All right, gonna go ahead and copy a note and paste. Here we go. Now this time, show using arrows the electron transfer between atoms of magnesium and chloride. Okay, so we're gonna go ahead and see how electrons get transferred around between metals and non-metals. Okay, now do keep in mind that one would have to completely give off electrons, while the other one accepts, right? So let's go ahead and start moving around. This one, magnesium, is going to lose an electron. It's going to go enter right over there, okay? Now that's it for this one, right? It seems like, okay, chlorine has now 8 valence electrons. It is happy, nice, and stable. But this magnesium to the left, it has still this extra valence electron that it wants to get rid of. So what we're going to have to do here, we're going to have to add in another chlorine here to the picture. 5, 6, 7, okay? So the other electron from magnesium is going to go ahead and stay right there, okay? So that's it for this one, all right? Showing arrows. Now, the resulting Lewis dot structure with all the ions created. So magnesium is now 2+ because it's lost 2 electrons. And each chlorine, 2, 3, 4, 5, 6, 7. And I'm going to go ahead and represent it with a green dot because just to show you guys that it's been gained by that magnesium to the left here. Draw a bracket, right? And how many electrons has this chlorine atom gained just now? Well, 1 minus. So it's no longer an atom. You have to call this an ion, right? Chloride ion, okay? Now, that's not the only thing. Only one. We had another one, right? So I'm going to go ahead and copy and paste it. There you go. 2 of them, all right? Okay, so now, in what ratio are they combining? So there's 1 for every magnesium. There is 2 chloride ions, anions, right? So the compound formula is going to be simply MgCl2. And the name of this is going to be called magnesium chloride. All right, that's all you have to do for ionic compounds. Just going to make a note here. No prefix for ionics. Don't forget about that, okay? It only applies for molecular compounds. All right, so speaking of which, we have a molecular compound that we're supposed to put together. Let's see. Show the Lewis-Dot diagram for nitrogen and hydrogen atoms. Let's see. Nitrogen, and here's hydrogen. Okay, so nitrogen has 1, 2, 3, 4, 5 valence electrons, and hydrogen has 1. Okay. Now, it seems like this nitrogen to the left has 3 sides where it is not fully filled, right? It has 1 of each. But if you look to the right, hydrogen here, it so happens to have 1 valence electron. So my assumption is that, okay, I'm probably going to be needing 3 hydrogens so that each hydrogen can go inside of that spot to the right of the nitrogen, below it, and to the left of it, right? So that's all I have to do for step A. And if you go to step B, show using lines electron sharing between atoms of nitrogen. Okay, so let's see. Draw my nitrogen like that. And I'm going to go ahead and draw hydrogen, just like that. Draw another hydrogen here. And running out of space here, but that's okay. Okay, so what's going to happen is using lines, right? So this is going to come here, this is going to come here, and this is going to come here, right? To form bonds. So this is what I mean by sharing electrons, okay? One major difference that molecular compounds is that it will share electrons rather than giving it off and receiving it, kind of like ionic compounds, okay? So the way that I like to compare this is that if I have a student here holding out a fist, that's a fist, okay? And I'm kind of like doing a fist bump. Here's my fist. If I do a fist bump, okay, what do? Well, we have now formed a bond just like that, a single bond, right? This is from me, Mr. Kim, and this is from the student, right? So 1 from the student, 1 from me, okay, each fist being an electron. We have 2 electrons like that lined up. They're being shared, right? So now student can say, you know what? Since we have this bond now, I have these 2 electrons. They belong to me. But at the same time, I'm thinking the same thing. I now have 2 electrons just like that. Okay? So that's the same thing that what nitrogen and hydrogens are doing right now. They're sharing electrons, okay? All right, so now they're going to be connected. So like that, like that, like that, okay? So it says bonds replacing shared electrons. So if you want to go ahead and connect and form a single bond for the electrons that are being shared. So I got a nitrogen bond, H, 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 just like that. Okay? All right. Not bad, right? Not bad. Show the resulting compound formula and name when the 2 form a covalent bond. Compound name, all right. So it's going to be, well, let's go ahead and write out the formula. Yeah, sure. NH3. All right. Now, to name this molecular compound, we have to use prefixes, but remember, if the left nonmetal is, if there's only one of it, you drop the name prefix mono. No need for that, right? So it's simply nitrogen. Okay. What's the prefix for 3? Tri and hydride. Okay, that's all you have to do. Okay, all right, let's go ahead and move on forward. Okay, I crossed out 13 and 14 because we don't have to worry about it. You're not tested on the characteristics or any of the properties of ionics or compounds, covalent compounds. Let's go ahead and start naming the following thing, writing the formula. Oxygen gas. All right, oxygen gas, the gas that we breathe in right now, we are breathing right now, is O2, right? Because oxygen is one of the 7 diatomic molecules, and you're going to find these diatomic molecules in nature always paired up, never by themselves. O2, okay? If you forgot what they were, it's have no fear of ice cold beer. Just remember the first letter of each word, okay? And that's H2, N2, F2, O2, I2. It's not C2, it's Cl2. It's not B2, it's Br2, okay? These are your 7 diatomic molecules, okay? So let's take a look. It's between oxygen and another oxygen. And we know that oxygen is a non-metal. So it must be a covalent compound, right? Good. That's all you have to do. O2 for this one. Okay? All right. Let's see. What about sodium chromate? Sodium chromate, we know that sodium is a metal, right? That's an Na. And chromate is actually, notice that it's got an 8 ending, which means you're not going to find it on the periodic table, but you're going to find it on the back side of it, right? It's one of the polyatomic ions. And you'll find chromate, and it's going to be CrO4 2 minus with a charge, okay? Now, what about the sodium here? Sodium does have a charge as well, which is 1 plus, okay? Now, let's go ahead and combine them so that we can cancel out the charges, okay? So I'm going to take this 2. Well, you need to do the crisscross method here, right? Because the charges are not the same. It's not the simple 1-to-1 ratio. So take this 2, let's bring it down here. And you're going to take this 1, we're going to bring it down here. So it's combined in 2-to-1 ratio. Great. So Na2CrO4. And that is sodium chromate. Ionic compound because it's between a metal and a non-metal. Okay? Carbon dioxide. Carbon is a non-metal. Dioxide is also, oxygen is also a non-metal. Okay? Between a non-metal and non-metal, it has to be a covalent, okay? Okay, carbon is missing a prefix, which is a clear indication that there's only 1 carbon. Di means 2, so we have 2 oxygens, okay? So, CO2 is all you have to do for this one. Okay, yeah, I'm changing up colors. All right, potassium bromide. Okay, how do we do potassium bromide? Potassium is a metal, and bromide is bromine, right? Which is a non-metal. So when you combine a metal and a non-metal, you're going to get an ionic compound, okay? All right, let's go ahead and write out its chemical formula. Potassium is K1 plus. Bromide, bromine, is Br1 minus. Oh, okay, so what do you know? It's 1 plus 1 minus. You don't have to do the crisscross method here, right? Because it's just simply combining in 1-to-1 ratio. Simply put KBr, and that's it. Okay. All right, let's go ahead and try the next question. Dioxygen, monochloride. Okay, so I got 2 oxygen. Mono means 1. Chlorine, chloride. So we're just simply combining in that particular order, okay? So that's O2Cl. Done. Okay, and that's a covalent, right? Between non-metal and a non-metal. Again, I see prefixes. That should be like an automatic, oh, that's a molecular covalent compound. All right, next one, iron 3 sulfate. Okay, so the reason why iron here has a Roman numeral is because iron could be 2 plus or 3 plus, right? It's got multiple charges. If you don't know what they are, it's okay. Look on your periodic table, and inside the element box, you'll notice on the top, there should be like 1 or 2 or even 3 charges depending on what element that we're looking at. And iron in this case, it seems like it's 3, right? So we know that, okay, this iron is Fe3 plus. All right, what is a sulfate? Sulfate, you're gonna have to look on the back side, and that's gonna be SO4 2 minus, and that is sulfate, okay? Because it's got the 8 ending, you're not gonna find it in the front side. Periodic table, back page. Okay, so it's got 3 and 2. It's not the same 1-to-1 ratio, so I'm gonna have to use a crisscross method. Sorry, I'm like writing all over the place, but don't mind me. 3, okay. So it's combining in 2-to-3 ratio, just like that. So Fe2. Now, okay, this is a polyatomic ion, and if there's more than one, you need to use parentheses, right? So open up parentheses, write down SO4, close it, and on the outside, you're gonna write 3 as the subscript underneath it, okay? Don't just multiply that and put down 12. No, because that's a different compound, all right? If it's a polyatomic ion, you need to separate it by using these parentheses. Okay, that's it for that one. Now, iron is a metal, sulfate is a non-metal, right? Or you could see iron is a plus cation, and sulfate, it's got a negative charge, so it's an anion. So cation and an anion is an ionic compound. Okay, all right, so let's go ahead and try G now. Just gonna clean up just a tad bit. There it is. Okay, let's go ahead and try to name this one now. SR. Okay, if you look on the periodic table, you'll find it on the left side. It's an alkaline earth metal, and it's in group 2, strontium, right? And strontium has a charge of 2 plus. What about this OH? Okay, first of all, OH it's got parentheses around it, right? So I know that, oh, hey, that must be a polyatomic ion. So if I look on the back side, you'll find that it's OH 1 minus, also known as hydroxide. Okay? All right. Now so we have a plus cation minus anion. So if it's a cation and anion, it's an ionic compound. All right? For ionic compound, you just write the first name as is. So that's strontium. Okay? And if it's a polyatomic ion, you don't need to change the name. You don't need to throw in the "ide" at the end. Just write down the name as is. Okay? Strontium OH minus is called a hydroxide. That's all you have to do. Strontium hydroxide. Okay? All right. I'll just do a couple more, I guess. Here's H. NH4 2CO3. Okay, let's see. Now, NH4, it's separated by parentheses, so it's a polyatomic ion. If you look on the back side, you'll find that, oh, that's a positive polyatomic ion. And that's actually called ammonium. Okay, so ammonium is NH4 1 plus. Okay, and what about CO3? CO3 is also found on the backside, and that's actually called a carbonate. CO3 2 minus. CO3 2 minus. Okay, so if you look on the left, here's a positive charge and here's a negative charge. So that's between a cation and an anion, which therefore it's an ionic compound. So if it's an ionic compound, the left thing, it's not just a metal, it's actually it's not a metal actually, it's a cation. You leave the name just as is. So I'm going to write down ammonium. All right, now carbonate, that is also a polyatomic, and you just leave the polyatomic alone, don't change it, right? Carbonate. Okay, done. That's all we have to do. All right, next one, we have a chemical formula, which means we're gonna have to write out its name, okay? So here's what I'm going to do. Copper, okay, copper is a transition metal and it has multiple charges, right? So we don't know which one this is. That's why we're going to have to work it out, okay? So on the right side, we have NO2, and there's two of it, right? NO2 is called nitrite. It's not nitrate, guys, okay? Nitrate is NO3, but this is an NO2. So that's called nitrite. NO2, 1 minus, okay? It seems like I have two of it, all right? So I'm going to write down another one right below it. So, okay, let's go ahead and add up the net charge here. 1 minus, I'm going to add that with another 1 minus. So that's 2 minus of net charge in total. Now, this is an ionic compound, right? Would you agree? Because NO2, which is nitrite, has a negative charge. And we know that copper, Cu, is a metal, which it will have a positive. So it's between a positive and a negative. So it must be an ionic compound. And we know that ionic compounds are neutral, okay? So zero charge, all right? Now, when I say zero, if I add the 2 minus charge with the charge of this 1 Cu, I'm going to go ahead and draw in a red box, okay? There's only one Cu, copper, right? Because it's combined in 1:2 ratio. So this copper, whatever the charge of that, it must make this 2 minus a 0. What is that going to be then? It has to be 2 plus, right? So this copper is actually 2 plus. Okay, cool. So I know that this is copper 2. Great. So how do I name this? Copper 2, okay, and nitrite. Done. Okay, all right, so I'm going to go ahead and stop right here. I've done a lot of these questions. The ones in the bottom are really just a repeat of a lot of the questions that I did above here, okay? I hope this was helpful, and enjoy.